using Unix domain sockets with Apache HTTP server and CloudBees CI. In Jenkins LTS version 2.426.2, support for Unix domain sockets was added. However, that support was not seen in CloudBees CI until version 2.440.1.3. The primary reason why is in order to use UDS, you also must be running Java 17. With CloudBees CI 2.440.1.3, Java 17 support was added, so therefore now we can use UDS. Now you might be asking yourself, what is UDS? Well, Unix domain sockets give you the ability to exchange data between processes executing, the key point here, on the same host operating system. So what does this really mean? Well, if I don't want to have open IP sockets on a machine, then I could use a standard process, much like using Apache HTTP server, and have that talk to my CloudBees CI controller over Unix domain sockets. This makes UDS a whole lot faster and lighter than using IP sockets. Just to wrap this up, since UDS exists only on the host operating system, we know for sure that they only execute on that host, so using other checks like routing can be avoided. This also makes UDS a lot lighter and faster than using IP sockets. So here's the starting point for this video. What we have is a CloudBees CI client controller. It's version 2.440.1.3. It's also being run on top of Java 17. Thinking back to what I just said, in order to use UDS, you have to be running at least Java 17. Now also on this server, I also have Apache HTTP server. The version for that is version 2.4.37. So let's go and take a look at how this is actually running. If we were to take a look at the URL, we can see that I'm running at cbcodes.com/cc11. Now, you're thinking, okay, wait a minute, I don't see an 8080 or anything else in that URL. That's because I'm currently using Caddy to proxy all traffic to both my operations center and my client controller. Now for this video, we're only focusing on the client controller. So what I have on Caddy, if we take a look at the configuration for CC11, I'm actually pointing to port 8080. Well, how can I confirm that? If I go into my controller, let's take a look at my log. If we scroll up and take a look at how it started up, what we can see here is there is a message during the startup phase where we can see that we have started server connector listening on port 8080. What we're wanting to do is eliminate that listening on port 8080 and actually have Apache take care of that connection for us. Now taking a look again at what we have here, we already have a reverse proxy in front of our controller. What we're wanting to have now is we'll have Caddy that is pointing at Apache. That will be going across sockets from 443 down to 80. And then from the backside of Apache, we'll be using UDS to connect down to our controller. Now we also want to make sure that our server is running as securely as possible. So that means we need to have our firewalld service also running. So let's check that out. Let's go back over to our controller. We'll quit out of this and let's go ahead and become root because that will make the rest of our job easier for this setup. Let's do a netstat-an. And what we can see here is that we are listening on port 8080. Now it's on TCP/6. Now what we'll also see here at the top is that we're also running port 80. So that is our Apache HTTP server. And in fact, if we go straight to the machine name, which in this case is C11, we can see the default Apache page for Alma Linux. So let's go ahead and check out our status for our firewall. So we'll say systemctl status firewalld. We can see that it's currently not running. So let's go ahead and start up our firewalld. If we check our status again, we can see it's actually running. So let's go ahead and refresh our page for Apache. We can see we can't find anything there. Now let's go back over to our controller and see what happens. We refresh this page and it goes blank. So right now the reverse proxy is unable to access this server. Let's go ahead and take a look at firewalld and see how the configuration is set up. So if we quit out of status and we do a list all on firewall command, what we're going to see is we have a number of services that are allowed, none of which are either HTTP or HTTPS. So we need to go ahead and add those two services to firewalld. So let's go ahead and add in our HTTP and our HTTPS as well. we can see both of those were successfully added. But if we were to do our list all again, what we're going to see is they're still not listed there. So what we need to do is actually reload our firewall. So we'll say firewall command -- reload. Now if we do our list all one more time, now along with the other services that have been there all along, we've now added HTTP and HTTPS. So now let's go ahead and double check our Apache server. And now we can see Apache is back up. That's port 80. But if we go back over to our reverse proxy pointing down at the controller, there's still nothing listening there. Now at this point, we're ready to start configuring our controller and Apache. So let's go ahead and go back over into our controller. Now remember, we were taking a look at our log and we saw that there was a server connector listing on port 8080. What we need to do is we need to disable that listening port, and then we need to go ahead and set up our socket. So let's go ahead and edit our sysconfig file. Sysconfig CloudBees core CM. And let's go all the way down to our Jenkins args section. What we're going to do is we're going to set the value for HTTP port to -1. That will disable the HTTP port listener, which in our case is port 8080. And now let's go ahead and add in the configuration for our Unix domain socket. What we have here is --HTTP Unix domain path var run CloudBees core CM / CloudBees core CM.socket. And let's go ahead and close that back up. So what we've done is we've modified our Jenkins args to disable the HTTP port to -1, and we've set our Unix domain path. Let's go ahead and save this, and let's restart our service. So we'll say systemctl restart CloudBees core CM. Now if we take a look at the status for our service, we're going to see that the process failed. Let's take a look at our log. And what we can see here is that it failed to start Jetty. If we scroll up a little bit more, we can see that it could not bind to Unix domain server connector. And then finally, we come back up to the root, no such file or directory. So when we specified the path for the socket file, it's looking to create the file in that path. Well, that path doesn't exist. And if we continue scrolling up, what we're going to see here is we could not bind Unix domain server connector to this file. So we need to create a directory var run CloudBees core CM. So let's quit out of this. Let's make dir -p var run CloudBees core CM. Now we'll also need to go ahead and change the ownership for that directory to the user that's actually running the CloudBees core CM process, which in our case is CloudBees core CM. So let's go ahead and chown CloudBees core CM, CloudBees core CM to var run CloudBees core CM. And then finally, to really lock it down, we need to make sure that the only user that can get to that directory is that user. So we'll chmod 700 var run CloudBees core CM. Now if we're going to take a listing of var run, and if we go ahead and scroll up and take a look at CloudBees core CM, we can see now that CloudBees core CM for the CloudBees core CM directory. Now let's go ahead and restart our service. So we'll say systemctl restart CloudBees core CM. Now if we were to take a look at the log file for our controller, we can see that it's starting up. And if we take a look at our started line, what we can see here is we started our Unix domain server connector at the location var run CloudBees core CM socket. Notice we don't see a server connector of 8080 running anywhere. And in fact, if we go ahead and quit out of this, and if we do a netstat-an and grep for 8080, we don't have any output for 8080. So we've been successful in swapping out the 8080 for our Unix domain socket. Now that it appears that our controller is up and running fine, if we were to click on our page going to C11 again, we refresh it, still nothing there. That's what we expect because remember that our existing reverse proxy is pointing at 8080 and there's no 8080 listening anymore. So at this point, we're ready to move on and change the reverse proxy configuration for our Apache server on this server. Now I'm assuming that you understand how to use Apache as a reverse proxy. There's a link to another video down in the description about how to do that if you've never done it before. Now, since we're using Apache to only front our controller, since it is on the same server, I'm taking an easy way out and just adding a configuration file. If you're already using Apache on this same server in your setup, then your configuration is going to be different. So let's go ahead and go back into our server. So we're on our controller server. I'm going to cd to etc httpd conf.d. Now what we see here for our Apache server is this is the standard welcome page. So if we take a look inside of confd, what I'm going to see is a welcome.conf. What I'm going to do is I'm going to go ahead and move that file and just rename it to old. Let's go ahead and restart our Apache service. And then if we come back over here to the test page and refresh this page, we're now going to see a very standard index page that shows nothing because at this point there is nothing. Now let's go ahead and create the reverse proxy for our controller. So we'll go ahead and say vi CloudBees core cm.conf. And inside this file, we're adding 2 lines. Proxy pass, and notice where it's mapping to, Unix : to our socket, and then it's piping to HTTP localhost no canon. We have a variation of that for proxy pass reverse. Again, slash, and then the path down to our Unix domain socket. And let's go ahead and restart our HTTPD service. Now remember, our existing controller is living at a location /cc11 below the domain name. So now what we need to do, since we're passing everything through, instead of it just being cc11, I'm going to say cc11 in my path as well. Now we can see that we're running with service unavailable. What does this mean? If we're going to take a look at the log file for our HTTP server, what we're going to see is that we are trying to connect to a Unix domain socket and we are failing. We can see that right here. So what's going on with this? Well, right now, the Apache HTTP server is running as Apache. And I need to make sure in order to use that socket, I have to be the same user as the socket owner, which in this case is CloudBees core CM. Now, before we add the user, let's take a look at the configuration, httpd-s. What we'll see here is there's a user and a group that are both Apache. So let's modify our configuration to have a user and group of CloudBees core CM. So we'll insert user CloudBees core CM and group of CloudBees core CM. Let's go ahead and save that and let's restart the service. And then let's run our httpd-s again. And we can see that our user and group are both CloudBees core CM. So let's go ahead and go back up here to our browser. We'll refresh this and we're still getting a 503. Now if we double check our error log file, what we're going to see is that we're still unable to connect to our socket. So at this point, because we're running on Alma Linux, SE Linux is enabled. So there is a configuration that we need to make for SE Linux. So let's go ahead and take a look at what the socket looks like. So if we do a listing -Z of our socket, what we're going to see is that the value here is var run t. That value is incorrect. It actually needs to be a different value. So the configuration change that we need to make is we need to change the var run t to this value for HTTPD on the socket file. So we'll go ahead and hit enter. Let's go ahead and check that listing again. And we can see now the socket now has this value. Now at this point, we shouldn't have to restart Apache because we just reconfigured SE Linux. So let's refresh our page one more time. Now we can see that we have a URL that routed us back to our operations center. So that means things are talking, but are they really talking? So I'm going to close this page because I know that Apache is aware and redirecting within the system of all of our CloudBees instances. First off, let's go to the operations center. Let's go ahead and log in. What we're going to see here is it appears that CC11 is actually connected and up and running and accessible. Let's go ahead and click on CC11 and then everything breaks. Well, let's think about it a minute. I haven't reconfigured my external reverse proxy yet to go ahead and forward down to port 80, which is where CC11 is actually running. Not on port 8080, but port 80. So let's go back over to my caddy server. Let's make one small change to our caddy configuration. And instead of going to 8080, what I'm doing is just now going to 80. Let's go ahead and save this. And let's go ahead and restart my caddy service. Let's go ahead and go back up to our Operations Center. We're still in. Let's go ahead and click on CC11. And what we can see now is that our controller is back up and available. But now, instead of it being directly from caddy down across port 8080, now I'm connecting from caddy down to Apache on port 80. That's on the same server as my controller, and the Apache server is talking to the controller over the Unix domain socket. If you have any questions or comments, you can reach out to us on X at CloudBees. If this video was helpful to you, give us a thumbs up. And if you haven't subscribed to CloudBees TV yet, why not? Take a moment, click on that subscribe button, and then ring that bell, and you'll be notified anytime there's new content available on CloudBees TV. Thanks for watching, and we will see you in the next video.